This section we're going to look at the properties of logs and a little expansion on that. I thought I'd do this decibel scale. Decibel is the relative loudness of something compared to the quietest sound you can hear. They call it the threshold of hearing. The quietest sound has 10 to the negative 12 watts per square centimeter. The loudest sound that you could possibly hear is infinite, really, but you can't hear things after a certain loudness because it just decimates your hearing. Think a jackhammer like 10 to the 20th watts per centimeter is about as loud as you can get. But what we're going to do is we're going to look at this formula, 10 times log, and when you don't see a base, we say it's base 10, of I over 10 to the negative 12. So we're going to put in a 10 to the negative 6 here. And if you notice that 10 to the negative 6 over 10 to the negative 12 is 10 to the negative 6. Actually, positive 6. Okay? So when you put this in your calculator, you're going to get 60 decibels. Pretty cool. It's almost like you took the difference and multiplied by 10. That's exactly what you did. Damage to hearing can start with a short-term exposure of 115 decibels. What intensity is that? So if you have 115 decibels, that'll be equal to 10 log base 10 of I over 10 to the negative 12. Okay? So 115, and if you divide by 10, you get 11.5 is equal to log base 10 of I over 10 to the negative 12. Now you're looking at that and you're saying, I can't solve that. I don't know what to do. But you do, because remember, you can always change log form to exponent. The base is 10. The logs are exponents, so this is the exponent. 11.5 will be equal to I over 10 to the negative 12. Okay? So if you multiply, you're going to get I is equal to 10, 11.5 times 10 to the negative 12, and negative 12 plus 11.5 is 10 to the negative 0.5 is equal to I. So there you go, 10 to the negative 0.5. You hear something that loud, it's going to hurt your ears. How does this compare with the threshold of pain, which is 140? So when you do 140, that's going to be 10 to the 4th, right? Because you're dividing by 10, or 14. And that'll be equal to I over 10 to the negative 12. 10 to the 14 times 10 to the negative 12 is equal to 10 to the 2. So this is the threshold. This is really loud, damage your ears. This is threshold of pain where it actually hurts, 10 to the 2nd. All right, so one more time, if you graph an exponent like 5 to the x goes through the point 0, 1, domain is all reals, ranges 0 to 1. But if you do a log here, it's going to start down here and go through 1, 0, and that domain is 0 to 1, and the range is all real numbers. So that's pretty cool. So that brings us to log properties. And the thing about the log properties is that all of the log properties are related to exponents because logs are exponents. So if we take this slide and review what happens with exponents, then it might make sense of what's happening with the logs. For example, if you had 2 to the 5th times 2 to the 3rd, that's 2 to the 5 plus 3. So logs are exponents. So do you see how these two being multiplied give you the sum of the log of x and y? Likewise, when you divide 2 to the 5th over 2 to the 3rd, you get 2 to the 5 minus 3. Well, here's your division part, and then here's your subtraction part. We also have 2 to the 3rd to the 2nd. Well, that's 2 to the 3rd times 2 to the 3rd, which is the same as 2 to the 3 plus 3, which is also the same as 2 to the 3 times 2. So essentially what you're doing here is you're saying it's 2 to the 3rd to the 2nd is the same as 2 to the 3rd times 2. And when you take these logs, see you have the log base a of x to the m, like this. That's like multiplying m times log base a. And I like to say it this way, is you're taking the power of the x and moving it up in front. And so now it's that times that. If that doesn't make sense to you, let's try another one. Let's try log base 2 of 3 to the 3rd. Okay? That's the same as the log base 2 of 3 times 3 times 3. That's the same as the log base 2 of 3 plus the log base 2 of 3 according to that multiplication one. So then you have that 3 times. Well, why not shortcut that and say it's log base 2 of 3, 1, 2, 3 times. So essentially that cube is just moved up to the front to get 3 log base 2 of 3. Now this one takes getting used to, but you'll get it. How about a change of base? Log base 3 of 7 equals x. Well, when we're confused and we don't know what to do with a log, change it into an exponent. So you're going to get 3 to the x is base 3 to the x equals 7. Now take the log base 10 of both sides. Base 10 of 3 to the x. Now, in a log, the exponent can be moved out in front. So I'm just going to call this x equal to log base 10 of 7 over log base 10 of 3. And that's exactly what I'm saying here. Log base 10 of the top number, 7, over log base 10 of the base, which was 3. That's super handy for finding logs with different bases. Now the easy ones. Log base a of a, I don't know what that is, so change it to exponent. A to the first equals a. So that totally makes sense. How about this one? A to the 0 equals 1. Well, that's true. So you know that's right. A to the what is equal to 0. Well, remember my graph? Did it ever get to 0? No. So this is no answer. This one we mentioned yesterday, and I just want you to start to get used to it. A to the log base a of x equals x. You can see this if you went 2 to the log base 2 of 7 equal to x. So change it, log base 2 of x equal log base 2 of 7. base number exponent. Okay, so what does x have to be in order for this to be true? Log base 2, log base 2, x has to be 7. So that's where you get a of the log base a of x equal x. So what you're going to do is using these, and these are the primary three, you're going to rewrite these using the properties. So this one is the natural log of x cubed plus the natural log of y squared. And remember that we can pull these out in front, and that's going to give us 3 times the natural log of x plus 2 times the natural log of y. And you can do that with all of these. Don't forget square root or fourth root. That's to the 1/4, and you could pull that out in front. Use properties of logs to put these into a single. So we're going to do this in reverse now. We have 4 natural log of x. Well, this is the natural log of x to the 4th plus the natural log of y to the 2nd. Since they have the same base, ln of log base e, you're going to have the ln of x to the 4th, y to the 2nd. So you're going to do these in reverse. These are super helpful. Use your calculator for these. This is great. Try these. We're going to do something with that in a moment. I call this fix my mistake. One time I was writing this lesson super late at night, and I wrote this slide down of facts, and all of them are wrong. Every single one. See if you can figure out what's wrong with each and every one of these. Something is wrong, and then what I want you to do is to fix it. And you can post these in the discussion board. Great activity. These are some properties that we talked about already. I just wanted to share with you the slide rule. A slide rule is the weirdest thing ever. All it is 2 exponential graphs lying side by side. So if you want to go 2 times 3, so I line this 2 up with this 1, and then I go up to 3, I should get, you ready for this? 2 times 3 equals 6. Huh? 2 times 3 equals 6. You try some. A classic one would be 4 times 3. 4, oops, didn't do that quite right. 4, and then I go to 3, is somewhere between 1 and 2, close to 1. How does 12 sound? Yeah. So you can use the slide rule, and the reason it works is when you have it in an exponential scale, 1 to 10 is the same as 10 to 100. Wait a minute. 1 to 10 is the same as 10 to 100. Then what you can do is when those scales are side by side, 10 to the 3rd times 10 to the 2nd will give you 10 to the 5th. So multiplication becomes addition, which is pretty cool. You can divide as well. I just have that for you to play with. I thought you might like that. And here are the problems. You use the properties some more. See if you can change bases. This one I thought was a little confusing. It says write down the expression of the log in terms of. So if you take the log base 10 of A, that'll be the log base 10 of B, log base 10 of C, and if you're multiplying, it becomes addition. Likewise here, it's going to be B squared plus log base 10 of B squared plus log base 10 of C, and if you have log base 10 of B squared, you can pull the 2 out in front and get 2 log base 10 B plus log base 10 of c. So there's A and there's B. You keep going with those. 3 is awesome. What you're doing there is you're given, this is a good multiple choice type question. If you know log base A of x is 0.009, what's log base A of x squared? Well, the 2 can come out in front. So you get 2 log base A of x. Well, this is already 0.09, so times 2 will be 0.18. And then you go ahead and finish the rest of those, and you should be good.